Hey everyone, welcome to This Explainer. I am so incredibly thrilled to have you here today because we're tackling one of the absolute most frustrating paradoxes in modern tech. I mean, have you ever wondered why you can sit down and interact with a cutting-edge billion-parameter AI model, something that literally commands the sum of all human knowledge, yet somehow it still manages to completely forget what you told it yesterday? Today, we're going to unpack exactly why that happens. And more importantly, we're going to explore the massive architectural breakthrough that's actually designed to cure it. Okay, let's dive right into this. The short answer, well, current AI models suffer from a fundamental, structural inability to accumulate experience across sequential independent sessions. You see, their parametric weights remain completely static after training. So that leaves in-context learning, which is basically just the text you cram into the prompt, as the single, only mechanism for real-time behavioral adaptation. And the problem is, the second you hit a transactional boundary, or when that context window resets, poof, the AI loses absolutely everything you just built together. The research actually defines this using a medical term, anterograde amnesia. Think about it just like in biological systems, right? When a patient can't form new memories. In AI, it's a systemic failure where the agent cannot form, consolidate, or recall persistent experiences across time. It essentially experiences the immediate present as just an ongoing, endless series of disconnected events. So every single time that context window resets, the AI basically wakes up with complete amnesia. It functions perfectly in the moment, sure, but it has zero understanding of the actual journey you've been on together. So here's our quick roadmap for today's explainer. First, we'll cover the illusion of AI memory. Then, enter the continuity layer. Third, the 7 properties of continuity. Fourth, the ATANT evaluation framework. Fifth, why legacy benchmarks fail. And finally, number 6, from interaction to relationship. Let's get right into it. All right, section 1, the illusion of AI memory and why RAG simply isn't enough. Now, the industry has absolutely recognized this amnesia problem. And honestly, they've tried to solve it primarily using a technique called RAG, retrieval augmented generation. But as we'll see in just a moment, RAG is fundamentally flawed if your actual goal is to build a long-term, evolving relationship with an AI. When we compare these approaches directly, the core difference is pretty glaring. Traditional RAG relies on semantic similarity search over static data, meaning it really just finds similar chunks of text. So imagine you tell it, I live in New York, and then a month later you say, I moved to London. A basic RAG system might just pull up both of those facts because, hey, they're semantically related. That leaves the AI totally confused. Cognitive continuity, on the other hand, reconstructs the current active state of a situation based on what actually changed. It knows inherently that London supersedes New York. There's a brilliant quote from Kinetic Labs that really captures this perfectly. It says, memory stores the past, continuity keeps the right parts alive in the present. And that's exactly it. True memory isn't just some flat database lookup. It's the systemic logic of knowing what still matters, what's been superseded, and how to reconstruct a coherent situational state. It's an active, continuous, living process. Which perfectly tees up section 2. Enter the continuity layer, featuring Continuum Memory Architecture, or CMA. To move past simple, static text retrieval, researchers are proposing a massive paradigm shift. CMA introduces a complete life cycle. It manages how memories are acquired, stored, updated, and retrieved, essentially shifting us completely from stateless retrieval to stateful cognitive continuity. So traditional RAG is almost entirely read path dependent. You dump text into a box and just sort of hope a clever search algorithm finds it later. But write path first architectures operate totally differently. Take something like decomposed trace convergence memory, DTCM. Or advanced frameworks like Mage, which stands for Memory as Agent-Guided Exploration. With these, when you tell the AI a fact, they decompose it immediately at write time, organizing that data into hierarchical state trees. Then, at read time, they don't just blindly fetch a document. They navigate those trees to dynamically reconstruct the actual current state of reality. It's a real game changer. Moving on to section 3, 7 properties of continuity, defining the architecture. Look, just saying an AI has memory is super vague. To prove this new architecture actually works in practice, we need a rigorous engineering-grade definition of what continuity actually means. And the research defines this through 7 strict, non-negotiable properties. Now, what's really interesting here is that these 7 properties aren't just theoretical ideals. They are highly testable requirements. While properties like persistence, temporal ordering, and model independence are incredibly vital, I really want you to focus heavily on 2 specific ones: Update handling and disambiguation. Update handling means the system revises the present truth without just erasing history. It knows you moved from New York to London, but it remembers you used to live in New York. Disambiguation means it keeps overlapping narratives totally separate. It doesn't confuse your brother's dog with your coworker's dog just because, they're both golden retrievers. These two are definitely the hardest to achieve, and they are exactly where normal retrieval systems completely break down. And that brings us to Section 4, the ATANT Evaluation Framework. Automated test for acceptance of narrative truth. If continuity is this brand new architectural layer, well, we can't exactly measure it with old tools, right? Enter ATANT. This is the new standard specifically designed to measure those 7 properties we just talked about. And crucially, it does so without relying on an LLM as some subjective judge in the evaluation loop. It is entirely deterministic. ATANT uses a really rigorous 10 checkpoint system. First, to test the right path. Basically, can the AI properly extract, index, and tag facts the exact moment you speak? Next up is the read path. Can it converge those multiple traces? The holy grail here is checkpoint 8, the final answer. This is the definitive, undeniable proof that every single expected keyword for a complex, reconstructed situational state is actually present in the final output. The other checkpoints, they simply diagnose exactly where the system failed if it didn't manage to hit checkpoint 8. Let's move along and see how this actually builds up across compliance levels. The framework tests the AI using highly realistic, multi-turn narrative stories that simulate human life. It scales all the way from 50 isolated stories right up to ATANT scale, which is 250 coexisting stories sharing the exact same database. Cumulative mode is the ultimate test here. Why? Because under high memory load, semantic similarity usually conflates distinct events. Testing 250 stories in a shared environment definitively proves if the system can achieve true disambiguation without cross-contaminating your life details with someone else's. All right, Section 5. Why legacy benchmarks fail. The measurement gap. Now, you might be wondering, why go through all this trouble? Why not just use the existing super popular AI memory tests out there like Lookups or Ruler? Well, the answer is that there is a massive structural measurement gap currently in the industry. When researchers analyze these legacy evaluations structurally, they found they fall incredibly short of measuring actual continuity. Take Ruler, for instance. It's essentially just a needle in a haystack test. It measures the capacity of a context window, not persistent memory across restarts. Then you have Long Mem Eval, which tests single-shot prompts without ever terminating the process, meaning the AI could really just be holding everything in its active attention span. And Logomo, which is highly cited for conversational memory, well, it relies on simple substring matching over long transcripts. The reality is, absolutely none of them measure true continuity across time. And get this, here is a truly surprising fact the researchers uncovered. The industry standard Locomo benchmark actually has a critical scoring bug directly in its open source reference implementation. When the benchmark expects an empty answer, which means the AI is supposed to say, I don't know, the code actually returns false for any answer provided. This bug renders 23% of the entire corpus unscorable by construction. It is literally penalizing the AI for correctly refusing to hallucinate. That is absolutely wild. So the crucial point is how this flawed testing impacts real architectural evaluation. The researchers took a highly advanced DTCM-based continuity pipeline called Nura, and they ran it straight through Locomo, and it scored a dismal 8.8%. Why? Because Locomo's sumstring matcher rewards verbose, lucky paraphrasing of transcripts and completely penalizes structural correctness and accurate refusal behavior. But wait, take that exact same Nura system, the one that just scored an 8.8% on Locomo, and put it through the massive ATANT cumulative scale with 250 coexisting stories. It scores a 96%. This isn't just some small statistical gap, it's an 87-point divergence. It proves unequivocally that long conversation substring recall and structural cognitive continuity are two completely different properties. When you visualize the data, the reason for this massive divergence becomes incredibly clear. If you map legacy benchmarks against those 7 required properties of continuity, the median legacy benchmark covers exactly 1 out of the 7 properties. Just 1. They almost uniformly fail to test update handling, reconstruction, and model independence. Basically, if you substitute a retrieval benchmark for a continuity evaluation, you're flying completely blind. Which brings us to our final section, Section 6, From Interaction to Relationship, the Paradigm Shift. If we just zoom out for a second from the architecture and the evaluations, what does this actually mean for us, for the users and the developers of AI? It represents a truly profound paradigm shift. The continuity layer is the missing layer between AI interaction and AI relationship. This right here is the ultimate takeaway. Memory isn't just a hyperparameter you can tweak on a weekend. It's not a clever prompt engineering trick. It is a fundamental architecture problem. By defining those 7 properties and introducing the ATANT framework, we finally have the tools we need to measure and build AI that actually carries its understanding forward. So I'll leave you with this provocative question to ponder today. The next time you log into your favorite AI tool, ask yourself, is this system actively building a relationship with me, or is it just hastily rereading a transcript every single time I say hello? If we want AI to truly understand us across the span of our lives, it's time we demand real continuity. Thank you so much for joining me on this explainer, and I highly encourage you to explore the ATN framework further to see the future of AI architecture for yourself. See you next time.